Hi, I'm Tyler. This is my project on forces. A force is a push or pull acting on an object due to its interaction with another object. It has both a magnitude and direction. Different types of forces that exist are friction, tension, normal, air resistance, applied force, spring force, and gravitational force. Newton's first law states that an object at rest and an object in motion stays in motion unless acted on by a net force. An example of this is a hockey puck sliding across ice. It'll then generally stay at the same speed unless friction slows it down or something else slows it down. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. It's explained with the equation F equals ma. An example of this is pushing something light takes an easier force, and something heavier is a harder force. So pushing something heavier will take more of a force, and something lighter, less of a force. Newton's third law states that if two objects interact, the force of object 1 onto object 2 is equal, but opposite the force of object 2 onto object 1. Every action has an equal and opposite reaction. An example is if you bounce a ball, the force that it hit the ground with, it'll bounce back up with the same force. For the perpendicular NEF problem, a car drives 100 meters north, then drives east 75 meters. What are the resultant displacement and direction? Step 1, you have to draw the triangle out. So it's going 100 meters north and 75 meters to the east. Then you have to solve for r by doing Pythagorean theorem. Then solve for the angle. Then you put those together and you get r equals 125 meters at 37 degrees east of north. For the non-perpendicular, a fly travels 5 meters south, then turns and goes west of north for 6.5 meters at 55 degrees. Finally, the fly goes due east 7.2 meters and it lands on a table. What is the magnitude and direction of the fly's total displacement? Step 1, you draw it out. Step 2, you label the x and y components and solve for x and y by using cos and sine functions. Step 3, you find the change in x and y. Then you draw that out and find the resultant and the angle. Then you could write it out and get the answer of 41.9 meters at 1.7 degrees south of east. There are multiple types of friction. A few of them are static friction, which is the frictional force that prevents two surfaces from sliding past each other. It occurs when an object is at rest and a force is applied to move it, but it hasn't yet started moving. An example is pushing a heavy sofa across the floor. It doesn't move at first due to static friction. 2 is kinetic friction. The definition is the frictional force acting between two surfaces that are sliding past each other. It occurs when an object is already in motion. An example is a book sliding across a table after being pushed. Number 3 is rolling friction. The definition is the frictional force that occurs when an object rolls over a surface. It occurs when a wheel or a ball rolls over a surface. An example is a soccer ball rolling on grass. Rolling friction slows the soccer ball down. Another one is fluid friction, which is drag. The definition is the resistance an object experiences when moving through a fluid, liquid, or gas. It occurs when an object moves through air, water, or any fluid medium. An example is a skydiver falling through air and experiences air resistance, a type of fluid friction. Thank you for watching my final presentation. That is my understanding on Newton's 3 laws and my understanding on forces and types of friction.